Alright guys, welcome back to the channel. My name is Danny. Today we're going to talk about my new project that I built in C called Fort Knox. So Fort Knox is basically a Bitcoin wallet, a Bitcoin hot wallet that I built using standard double SHA-256 and HMAC hashing algorithms. It's pretty much a complete wallet implementation, and you're able to generate a new wallet or recover an existing wallet. And from the seed, you can derive as many addresses and key pairs as you like, and they all have been tested with the official test vectors to make sure that the key derivation is correct and accurate. But with that being said, please, this is for educational purposes only. I am only one single developer, and you should never trust a single developer. As per the Bitcoin ethos, don't trust, verify. Experiment with tiny amount of sats at your own risk. Do not, keep in mind that any funds sent to this address derived by this wallet could potentially be lost forever. So with that being said, feel free to check out the README, look through all the explanations, and then we have the instructions on how to run the program locally on your machine. I wrote this code in Linux, so you need libgcrypt, libcurl, JSON, GCC compiler, and then go ahead and clone the repository here. So once you do that, you can go ahead and cd into the src, and as you can see, I have the make file already. You can just use that with sudo make, and clean, and then sudo make. All right, so let's get right to it, and we're going to start the program right now. /Knox. All right, as for the first command, price, self-explanatory. Just get the most recent price. And then the next one is new. Okay, so what that does is create a new Bitcoin wallet. So first thing first, you got to select your recovery seed phrase word count. That's the number of entropy. So the higher the number of entropy, the more cryptographically secure your seed is going to be. However, the higher the number, the more words that you're going to have to memorize. The mnemonics C words that you're going to have to memorize and be responsible for. So I do recommend the highest possible, which is 24, but it is up to you. So for me, I'm just going to go with 24. Let's go. Would you like to add an additional passphrase? So let's go ahead and talk about the passphrase, the concept of passphrase here. Okay. So entropy, 24 words. How many bits of randomness? Choose the highest one. It's going to translate that into a very large number, and it's going to be attached to the mnemonic C words. Basically, it's a standardized ways to separate the bits into random words that you can memorize and keep safe, and that's going to be your pretty much your entire livelihood. And then from that, you're going to generate a seed phrase, which is 64 bytes. And after that, you have an option of adding a passphrase if you like. Now the passphrase, think of it like the 25th word. It's almost like an extra vault that sits inside of the large vault that is your seed phrase. So your seed phrase is blue, right? It's the big vault. If you add a passphrase, it's going to add another small vault inside of it. And any Bitcoin that you send to this wallet is going to be inside of this green vault. Meaning that even if you have the seed phrase and the 24 mnemonic C words, you may be able to get into the blue box, the blue vault, but you won't be able to see what's inside or control the coin that's inside of the green box. So if you do put on a passphrase, make sure that it's your responsibility to keep track of that passphrase just as much as you keep track of the 24 C words. All right. So with that being said, I'm going to go ahead and add a passphrase because I like passphrases. Yes, I'm just going to say Fort. Okay. So as you can see, it's going to give you your 24 mnemonic C words here. So definitely write this down. Do not copy it. Do not take a picture of it. Do not save it on your phone. Store it on Google Drive. The C word should be far away from anything that touches the internet, period. And also keep in mind, like I said, you did choose, if you did choose to put a passphrase in, then it's your responsibility to also keep track of that, because if you have all of this and you don't have that, then you still won't be able to access your funds. Okay, so because this is a educational purpose only wallet, I'm gonna copy that and I'm gonna just keep it here. Okay, boom. All right, so now that I have the C word, a master key has also been generated for me from that C word and saved in session. So once the program exits, nothing will be saved. So you're gonna have to recover the wallet again. But as long as you have the program running, now you have an official wallet, so to speak, set up, and it's gonna have your C words, I mean your seed phrase, your seed, and your master key already generated. And we'll go deeper into the master key, so in a little bit. Okay. All right. Now that we have that, let's see what's next on the menu. We have recover. We'll go into that later. Oh, you know what? Let's demonstrate recover now. So I'm gonna exit. All right, and then I'm gonna run the program again. So now we're back fresh from scratch. It doesn't have any seed saved right now in session, so I'm going to use recover 24 C words, and I'm going to use the same exact words that I had earlier here. Yes, I do have a passphrase on top of that, and keep in mind the passphrase is case sensitive. All right, so then now we're back. You know, I just recover my C words just like that. So the next thing is key. Key is basically just a way to serialize your pub key, extended pub key, so that you can send it out to a watch only wallet, and that wallet would only be able to generate more addresses and see your Bitcoin balance, but it's not able to control your coins because it doesn't have the private key. I apologize about that. It's supposed to say master public key, not master private key. So if I choose master, it's gonna serialize my master public key, and if I use that, and I will serialize basically, and I use it for a watch only address, I can see the balance of my Bitcoin. I can also generate addresses from it, but if I wanted to move the Bitcoin, I can't do it. So it's actually a very cool feature because it keeps your coin safe, and all you're doing is just able to see it. It's a watch only wallet, right? And so the same thing with the account. You have to choose what account you want, and it's going to be usually recommended just to use 0. And once again, there's your serialized base 58 encoded address. All right, so the next one is balance. So balance is pretty easy. It's going to query the blockchain. It's going to query a total of 40 addresses, and we'll look into how the addresses are queried or generated, and then it's going to see if you have any money, any Bitcoin associated with these addresses, and that's going to be your balance. So if I go 0, I have no Bitcoin. Obviously, I just made this wallet. I'm going to have to send some sats to it in order to have some funds. But let's explain how the addresses are generated. So basically, as you can see here, this is the path that's already been written in the BIP-84 proposal, and this is just the standardized path that we use. So M is the master key. Okay, so from the seed, which is the most important part, the most important, the most significant, the most consequential is the seed. You generate a master key pair, right? And the key pair, I would say arguably is just as important as the seed. Now, keep in mind, a key pair is 2 keys, the private key and the public key. And at no circumstances or at any level would you want to expose your private key to someone else. You can give out your public key, and it's relatively safe to do so, but you should never give anybody your private key at any level. And of course, the higher the level, the more consequential that private key is, because it's then able to generate all the subsequent level underneath it. So this is M, the master key pair, and then we go to the next step, which is the purpose. So from the key pair of the master key pair, we generate the purpose key pair, which is going to be 84. That's the standardized number that we use. And then the coin type, that's going to be 0 for Bitcoin. It has different numbers for different altcoin, but we will only focus on Bitcoin here. And this means it's hardened, and basically it's just an extra large number. And we're going to be deriving from the parent private key instead of the parent public key. The coin key pair, and then the next one is account key pair, which is the account number that you want to use. You can choose between 0 to infinity. However, most wallets implementation checks all of your previous accounts. So let's say if you pick account number 3 to use, it's going to check account 0, 1, 2. And if account 0 has not been used, it's going to go ahead and tell you that, hey, we're going to use account 0 because you haven't used this account at all. So it's always going to use the first, it's going to use the first unused account. And you can't really override that for the most part. So usually we just go with 0, and accounts, it's basically just, let's say a lot of people like to separate their different Bitcoin addresses. So account 0 maybe is their checking account, account 1 maybe their savings account, account 2 maybe accounts that they are comfortable with giving out the public key to people with, so on and so forth. It's up to you, but usually 0 is just fine. And then the next level is the change key pair. Change key pair is either only 1 or 0. 0 is external, meaning you give it out to people and they'll send sats to it. 1 is reserved for change back. So a lot of times when you want to send Bitcoin, you're going to have to use a chunk of Bitcoin. It's called UTXO. That's a lot larger than what you really want to spend. So you would send, let's say, a UTXO of 1,000 Satoshis to your buddy, and you only want to give him 500. Then the remaining 500 will go back to you as change. And that's where you use the change key pair for 1, which is internal. And then after that, finally, we derive the address key pair. Now the address is just an index. Once again, it's similar to account. Try to use the first unused address. So start from 0. You can go to infinity if you like, but most wallet implementation does have a gap limit, meaning that they will only check for up to 20 addresses, and if they see that 20 addresses are empty, they're going to stop checking. So let's say if you have Bitcoin sent to address 1, and then the next time you get Bitcoin sent to address 23, for example. So as you can see, there's a 22 address gap between that. So your address, your wallet will only check address 1, and it says, oh, okay, we see some Bitcoin here, all right, and then it'll keep checking all the way to address 21, and then it'll stop because it says that, oh, I already reached my limit of 20 empty addresses. So then you won't be able to see your Bitcoin that was sent to address 23, right? So be very careful with that, but that doesn't mean that you don't own that Bitcoin. You do own it. It's just the wallet doesn't see it, and you're gonna have to basically override it somehow if you want to be able to see it or access it or control those coins. So usually just follow the good rule of thumb. Always go to the next address incrementally, all right, and never reuse an address. If you use an address once already, use the next one. Don't use it again for privacy and safety reasons. Okay, all right. So where are we at right now? We're on balance. We have no coins. Okay, the next one is fee. All it does is just fetch to see a query, an API to see what the current free market rate is for transaction fees. So basically miners, they work off of fees. So in order for them to mine your transaction and put it into the block, you're going to need to pay them. And the higher the fee that you pay them, the faster it's likely to get added to a block, because miners just want to make as much money as they can. So it's just capitalism. If you want your transaction to get included and get added to the block as fast as possible, you would want to jack up the fees and maybe use the priority fee instead of the regular fee. Okay, so what's the next one here? Receive. All right, so now this is where we really test the wallet to see if it works. So when you use the command line receive, you're looking to get an address so that you can send Bitcoin to it. So like I said, we recommend using account 0 as per the BIP-44 standard, but you can enter any number you wish. For this particular wallet, I limit it to account 0 to 3 because it's just too many. I don't want to, it's just it just get too jumbled up, tangled up, and it's a lot of complexities, and I don't feel like doing that, especially for a wallet of this scale. This is educational, so 0 to 3, 0, 1, 2, 3. I recommend 0, and once again, this wallet uses BIP-84 derivation path, which is the path that I showed you earlier, and this is native SegWit P2WPKH, pay to witness public key hash. All right, and the addresses will always start with BC1Q. So now let's go ahead and try that. I'm gonna use account 0. Boom, it just gave me a new address, and if I do receive again, it's gonna generate a different address, but I'm just gonna keep this one. So I can use a Linux tool like QR encode in order to get the code into a QR, so that I can just use my camera on my phone and just take a picture of it, and my Strike wallet or whatever can just send it straight to that address. So I'll do that right now. Actually, I'm gonna start a new program. Let's see there. Project Knox /SOC. Okay, so we already have that. That was an old one. Let me go ahead and delete that. FQRcode.png. All right, so now let's see. I'm just gonna copy the whole command here. Make sure I get the right address. It stops at CCJ. Cool. Back. Boom. My bad. There you go. All right, now let's go ahead and get that QR code. All right, so then now I'm gonna go ahead and use my Strike wallet and send a little bit of Bitcoin to this address, and I'll get right back once it gets confirmed and the transaction hits. All right. All right, while we wait for the transaction to hit, to get confirmed, so that I can have some Bitcoin on my wallet, I'm gonna go ahead and go over some of these graphics. So just to demonstrate, as I said, this is a hot wallet. Basically, a hot wallet just means that you're trusting to put your C words into a device that's connected to the internet. And so it's very vulnerable to malware and hacks and all of that stuff. And whoever the wallet developer is, or whoever owns the application or the program, you don't know if they might have a backdoor, or they're storing your C words somewhere in memory, or in a database. You just don't know, and it's very easy for them to get attacked, and they'll lose your coins. And so anytime you see a hot wallet, just think internet connected device, and you should always be very careful, and you should only keep very small amount of funds on a hot wallet, because it trades convenience for safety. Because it's nice to have a wallet right on your iPhone so that you can just send sats back and forth, but it's not very safe. And so it's good for you to keep maybe like a few $100 max, if you want to use that as like a checking account, kind of like carrying cash, right? It's not very safe, but hey, if you lose it, it's not the end of the world. You're not losing your entire life savings here. As opposed to a cold wallet, which is where you put your C words into a device that has never touched the internet. And so it's much more secure and less vulnerable to malware and hacks and attacks. And there's even a higher version, which is called an air-gapped cold wallet, which means that it won't even use a USB cord to plug into the internet. It completely air-gapped, meaning it never touches the internet at any point not even by wire. So it's very safe, right? And so you trade safety for convenience. You know, it's not very convenient to always have to pull out the hardware wallet or the cold wallet, and you know, and every time you want to make a transaction, you got to pass the SD card around, and that's the only way. You know, it's a lot more hassle, but it's a lot safer and much more you know, much better for your peace of mind. So that's the difference between a hot wallet and a cold wallet. And of course, Fort Knox, the application that I built, is a hot wallet. And once again, educational purposes only. Do not use it for any large amount of funds, and I'm not responsible for you losing your funds or your sats. Okay, so the next one, how we generate from a master key, this is how we look up addresses, right? Just to see how much, whenever you query for your balance, this is basically what goes on under the hood. The application would take your master key, it would derive for external chain and internal chain, so that's two different chains. It's going to loop through that, and it's going to get 20 address key pairs. So that's a total of 40 addresses, 0 to 20 for external chain, which is 0, and then 0 to 20 for the internal chain, which is 1, just to get all of your Bitcoin that was sent to the external chain, as well as all the Bitcoin that was sent to your internal chain, which is your change back account. And out of that, we're going to get the 40 addresses total, and then that's how we query and see the balance that you have. Like I said, you may have coins that are associated with an address that's outside of this range, but that doesn't mean that you don't have it, or you lost it, or you can't gain access to it. It's just because of the gap limit and wallet implementation. A lot of time they keep the complexity relatively low, so they respect the gap limit, and they only look up to 20 addresses per chain. Okay, and that's that. And then whenever you generate an address to receive Bitcoin, like I just did earlier, what you do is, what the program does is, it takes your master key and it generates the first unused address index, and then it'll hash the public key associated with that key pair, and finally convert it to an address with BIP-32, which is makes it human readable like this. And then you can translate that into a QR code, and you can just take a picture of the QR code. It makes things a lot easier, but it always starts with BC1Q. That's just the way the native SegWit BIP-84 implementation, that's just the way it works. And the last 6 characters is going to be the checksum. So basically a hash of the entire thing, just to make sure that you are typing in the correct address. But you should never type in an address anyways. You should try to use a QR code, if anything. All right, and then so finally, let's talk about key pairs and what that means. So once again, this is the path that we use for BIP-84 native SegWit. So M is the master key. From M, it's a key pair, right? Each one of these is a key pair. When I say key, I mean key pair. It's going to be a public key and a private key. Private key, never expose it. The public key, it's okay to give it out. Okay, so from M, the first level, the highest level, the master key, you're going to generate the purpose key, hardened, right? So that's going to be the 84 index, hardened, okay? And from that key, you're going to generate the coin type key, which is going to be 0 index, hardened, because Bitcoin is 0 and all the other indexes are for altcoins, but we're not concerned about altcoins for this video. And then we take that and then we derive the account key. So as you can see, it's deterministic, right? And it uses a hierarchy. So you know, if you don't have one, you won't be able to get the next one, so to speak. So we go to account. Like I said, account can be from 0 to infinity. Recommend you to keep it simple, keep it 0. And then we'll go to the change address, which is the external, right? It's going to be 0 or 1, 0 for public facing and 1 for change back. And then I'm sorry, this graphic is missing the final one, which is the address index, which is the final key pair that you use to generate your receiving address from. So yeah, with that, so let's explain how it works, what public key and private key means, because I think a lot of us are confused with the concept, and it sounds confusing. But just think of an address, like let's say the address that I generated earlier, just think of it like a lock. it's not exactly an address, right? It's not like, oh, send me, send me some stuff to this address. Like, no, it's a lock. So basically, let's say if you here want to send money to Bob, and Bob gives you his address, that address is essentially a lock. Bob just sent you a lock and say, hey, lock up the Bitcoin for me with this lock, please, right? So then you say, okay, cool, Bob. You take the Bitcoin that you want to send him, you take the lock, and you lock it up for him, and then you send it back. So of course, no one else can intercept this Bitcoin, because even if they intercept it, they can't do anything with it, because the lock is they don't have the key. Only Bob have the key. That's the private key that Bob keeps for himself. So when you send that Bitcoin back with the lock locked on it, Bob's gonna take that, and then whenever he wants to spend that Bitcoin, he can just use his private key to open the lock, which is the public key. So as you can see, that's the relationship between the public key and the private key. And so if you think about it, coins never really actually move. Like, it never physically move. Not even in cyberspace. Not even on chain. It doesn't move anywhere or get transferred, or like, oh, you're not actually sending anyone any coins. You're just locking and unlocking. That's all you're doing. It's just constantly people just locking coins, and then someone else unlocking the coin, and so the coins actually stay in place. It's just a lot of locking and unlocking, locking, unlocking. That's what transactions are, right? So, well, yeah, that's pretty much it for now, and let's check back to see if the Bitcoin that we sent has been confirmed. Alright guys, we are back, and it looks like the transaction has been confirmed. So let's check it. Balance 0. Boom, there it is. So I sent 4,255 Satoshis, which is about $5 right now. I'm sorry, I need to get the price up to date so that it can give you the most accurate price of basically how many BTC you have in dollar term. But yeah, so then it got confirmed. Just to make sure that everything is working, I'm gonna exit everything now, and I'm gonna rerun it again. I'm gonna recover the same address. I mean, the same C words that we used earlier for our address. I mean, wallet, and then yes, boom. So just to show that we have the same amount, balance. And there it is. We have 4,255 Satoshis that just got confirmed. So now you know that the address generation works, and you're able to receive Bitcoin with this wallet. But once again, like I said, it's only been developed by me. It's educational purposes only. So now let's go to the next step, which is to send the Bitcoin. Right? This is the more complicated code right here. So feel free to dig into it and look at how I implemented it. It actually gave me a lot of headache. The send function. So same thing with send. You're gonna have to pick an account number, and so it's gonna query all of your UTXOs just to see that, basically to see if you have the right UTXO, if you have the right amount of funds to be able to send to whatever address you want to send to. And maybe we'll explain the UTXOs in a little bit, but for now, let's go ahead and query, boom. So as you can see, it found the UTXOs. After querying the blockchain, it says, hey, I saw that you do have 4,255 Satoshis. That's cool. All right, let's go ahead and use it if you want to send it. So I'm going to use the address, my Strike wallet address here. Boom, paste it in. Make sure you verify it very thoroughly. Boom, it asks you for confirmation. You say yes. All right, so then now I have 4,000. So let's go ahead and send 3,500. How about that? 3,500 Satoshis. Okay, so let's do 150 sats for fees. Replaced by fee. I'll explain that later too. So say yes for that, and it's signed. It signed the transaction. Well, it built the transaction, signed the transaction, and there it is. It's working. It's sent perfectly, and I'll make sure that just show you guys that it's legit. Here's the transaction ID. Here I'll copy it, right? 733 BB. I'll go over to mempool. Mempool.space. Okay, here we go. Let's see. I'll type in the transaction ID that was given, and there it is. There it is, guys. the transaction. Hasn't been confirmed yet. Waiting for a miner to pick it up, but it looks like we should be next. Yep, 4,255 Satoshis being sent. So as you can see, there's two different outputs, right? One goes to Strike. That was the address that I use. Where is it at? Right here, right? PK3U. That was my Strike address. So it went there, and then the remaining amount after the fees, the change back went back to this address, which is my address. So I still have 605 Satoshis. Okay, very cool. Very cool. All right, guys. All right, so now that we're waiting for a miner to pick up our transaction, our send transaction, it's already in the mempool. So that's a great sign, but we just got to wait for a miner to pick it up. So while we're waiting for that to be confirmed, I would like to go ahead and explain UTXOs and what they mean. Okay, so UTXO is basically unspent transaction output. What does that mean? Basically, Bitcoin to a developer or to anybody really that uses the Bitcoin network, Bitcoin is only either one of two things. Either is an input or an output. Input goes into a transaction and output comes from that transaction. So if I'm the one sending Bitcoin, I'm gathering inputs, right? And then I'll send it to Bob, and Bob receives the Bitcoin, and that's the output. So the next time that Bob wants to use the Bitcoin that I sent him, maybe to send it to Alice, he's gonna go through his output, which is now his input, put it into the transaction and send it to Alice, and Alice is gonna get it as output. So basically, unspent transaction outputs just means that this is basically the Bitcoin that you have, pretty much, that you have available that's able to be used for your next transaction, right? So and also to expand on that, whenever you make a Bitcoin transaction, it actually has a weight and a size, a virtual size, a V-byte. So basically what that means is on a very conceptual surface level, the more inputs you put into your transaction and the more outputs you put into your transaction, the heavier the transaction is, and that's going to be higher fees. So the fee is going to be higher because it's heavier, right? So if let's say if you're trying to send to Bob 1,000 Satoshis, right? And you're using 10 different inputs. Each one of them is 100 Satoshi, 100 Satoshi, 100, 10 inputs, and then you're sending it to Bob. That's a lot of inputs. So then the transaction fee is going to be pretty high for that transaction. Versus if you only use one single input of, let's say 1,000 or 2,000 Satoshis even, that's going to be a lot less heavy, and so the transaction fee is going to be a lot lower. And the same thing with the outputs. The more outputs you put in to your transaction, let's say if you're using 1,000 Satoshi as one single unspent transaction output, and then you're trying to send it to 5 different people, right? You're sending Bob 200, you're sending Kim 300, you're sending Lindsay 100, all of that. That's going to have a lot of outputs. It's also going to be a lot heavier, so then the transaction fee will also be bigger. So basically, rule of thumb, you want to keep the input and output as low as possible. So that's why in general you want to keep your unspent UTXO, your unspent transaction output. You want to consolidate them. That's a term that's a little bit more advanced, but basically you want to take the smaller change you have and combine them so that you have one big output, so that whenever you want to send Bitcoin, you could just use that big output. It's like a big $100 bill, right? Rather than pennies or $1. Okay, so that's what transaction fees. That's how they're calculated. Of course, it's a lot deeper than that. It's a lot more complex, but that's the surface level understanding of it. And then when you have the transaction, you have to sign it, and the signature and the public key that you have to give up in order for the Bitcoin protocol to confirm that you signed the correct transaction and that everything looks good and that there's no fraudulent data in there, and that there was nothing that was tampered with. The hash has to match all of that, and then you provide a public key that's associated with the private key of the input that you're using, right? Because if you don't have the private key, you're not able to, you can't use this. This is not you need the private key in order to unlock that input. So instead of just giving up your private key to people, you don't want to do that. So you're going to give the public key instead, and you sign it, and the signature is going to have the relationship with the private key, so that anybody, so that the mempool, the nodes can just check to make sure, like, oh yeah, if the signature matches, it works, right? And then it gets broadcasted to the Bitcoin protocol, the network, and then it'll spit out a transaction ID for you to check it on the mempool. Okay. So the final functionality that we have is the RBF. Okay, RBF is basically it's called replace by fee, and so all it does is, so let's go ahead and break it down. So think of this as a mempool, right? Your transaction goes here and it just kind of waits, right? It's waiting for a miner to pick it up and add it to a block. But like I said, miners, all they care about is making as much money as possible. So let's say if you use a low fee, right? You set your fee too low, and then there's like traffic congestion, or it just the fees, the average fee rate just go a lot higher than you anticipated, and then now your transaction just stuck here, right? And the problem with that is, by default, the mempool will keep your transaction in the mempool for 2 weeks, and then after that, it'll fall off, right? But the annoying part about that is that during that whole 2 weeks, you cannot use the same input that you already used in this transaction for a different transaction. So you kind of got your funds just kind of stuck, right? So what replace by fee does is it gives you the option to, if you have it turned on, to basically go in and modify this transaction, double the fees, and then add a new transaction, and the miner will automatically know that, hey, this is a replace by fee transaction. I'm gonna pick up this transaction because it has more fees, and this transaction will then just fall off, right? So basically, you're able to modify and tweak the fee amount so that you can entice the miner to pick it up, because they want to make more money, right? Now keep in mind, the protocol says that replace by fees, you are not allowed to change the input or output. So you're not allowed to put in an extra input here, or you're not allowed to put in an extra output here, or take out an output here, or take out an input here. You have to keep the input the same. So if you have this transaction, let's say one input, 1,000 Satoshis, right? That one UTXO, and you want to send it to Bob, 500 Satoshis, and then you want to get your change back of 400 Satoshis. So the miner automatically get the remaining 100 Satoshis as fees. So the miner, whatever is not being spent here, that's left over, they're gonna automatically claim that as a fee. Like, so a lot of time people actually make mistakes to where they type in the wrong amount, and miners end up getting a lot more fees than they were supposed to get. And tough luck. That's the thing about Bitcoin. You can't really undo anything. It's self-sovereignty, and it's a lot of self-responsibility, right? So yeah, so let's say you have this transaction that's stuck in the mempool because you only have the fees for 100 Satoshis, and then the congestion of the network jacked up, and then now the average fee rate is like 150 instead of 100. So then your transactions keep getting pushed back and back and back. It's just stuck there, and you're like, man, this is annoying. Like, Bob wants his money, he can't get it. So what can I do? Well, you can use replace by fees, and what that does is it'll take the same exact transaction. It'll copy the input and output. Like I said, it can't modify the input and output, but what it can do is modify the amount to one of the outputs, right? So instead of you giving yourself a 400 Satoshis change back, you basically you tone it down to 300 instead. So then the miner is like, oh wow, cool, now I get 200 Satoshis left over. So then now this new transaction is going to be much more likely to get picked up by a miner and get added to a block. And then once that happened, this transaction, the old transaction, automatically falls off. So it's actually a really cool functionality that allows you to not get stuck in limbo, so to speak. So we do have that also. I can't really test it because the fees is so low right now on the mempool that anything that I try to put in the mempool, it's gonna get confirmed almost right away. So there won't be in order for RBF to work, you need to give it a transaction ID of a transaction that's stuck in the mempool. And if it queries that transaction and it sees that, oh, it's actually not, it's already been added to a block, it won't allow you to continue. But basically it does work if you guys ever feel the need to use it. I actually spent a lot of time working on the code to make it work, so I wish I could test it, but yeah, right now I can't. All right, so that's it, guys. I hope that helped. I hope that helped you understand the Bitcoin network a lot more and how everything works. And I invite you to dig deep into the code and see what the program does and all of its functionality and all of that, okay? And you have any question, let me know. And thank you for watching. Everybody, please have a great day.